Hello and welcome to Code with Sar. I am Sar. How are you doing? This is the second iteration that we're going to talk about data syncing. In the last video, we decided to break a database down to folders and files so it becomes distributed, supports offline operations, and got rid of the requirement for central hosts. In this iteration, I'm going to introduce you some challenging scenarios that I encountered during the coding and one ground rule that I discovered lately that addressed all those challenges. It is simple to follow, it addresses the challenge well, I'm very satisfied with it, I'm excited about it, and I want to share it with you. Without further ado, let's get started. For those new to the channel, this is the main data that we are going to be saving and syncing. Actually, now that I have some implementations, let me show you how they look like when they are on the disk. Here you see a list of folders. Each folder is used for a category. For example, 401k, aerobic exercise. What can go wrong? Oh, what can go wrong? Yes. If you're wondering why it ended with the %003f, take a look at my other video talking about file name encoding, and I'll put a link to the right upper corner. Inside those categories are data files. For example, in 401k savings, there's year, month, and there is one data point here. What we are seeing, on October the 1st, 2021, the value for the data point in 401k is 4,215.53. And those data points are the data that we need to keep syncing in between clients. And I think you still remember, the adding scenario is relatively simple. Imagine there are two clients, one desktop, one mobile, for example. On the desktop, we create the first data point, F6050D5F in 401k. And then, on the mobile, we created another data point. It is also in the category of 401k, but it will have a different ID. So when sync happens, it doesn't matter which clients start the sync first. Both data points end up in the OneDrive without any conflict. So what exactly is the challenge? Let's take a look at the deletion. Assuming we delete the file from the desktop, when sync happens, the file got pulled down. Here comes our first challenge. In the two-way syncing system, deleting data by deleting the file is not going to work. We need some strategies to deal with that scenario. There are some existing ones. Let's put some analysis around them. The first one is to totally avoid deletion. That might be an option for systems like logging, that once a log message is there, you might never want to delete it. But it won't fit for us. It is a legitimate scenario for the end user to delete a point. A second strategy is to use logical delete. Sometimes it's called soft delete as well. One implementation is to set a boolean of is deleted. For example, this converts the delete to edit. Since the file will not be deleted, it won't have the problem that a deleted file got restored. But it will have other problem that I'm going to show you in a bit. Let's go over the third strategy first, and that is tracking deletion. That is, to use a separate file to track deleted data. It's kind of like you have a recorded deletion. As long as we keep the integrity for the deleted data points.txt in this case, it seems like this strategy will work for us as well. However, the precondition to keep the integrity of the record file is not easy. Let's go deeper, shall we? Mix-up deletion and editing across multiple clients makes the scenario so complex. Let's keep building the example. Assuming we have everything in sync. Now, I delete a point from the desktop client. Before any syncing on the mobile client, I have the same point updated to a new value. Now, the desktop upsyncing the data. The first problem is that the application will not know whether to take the deletion or keep the 100. To a degree, that is solvable. For example, we could put a rule there stating deletion always when, so that the data on the remote will be deleted. Okay, let's move on. Now the mobile client starts to sync. There's yet another conflict. According to the rule that deletion always when, the data of 300 would be missing. But if we keep the value of 300, it would break the rule. The deal is, there's different situations. Sometimes we should keep this 300, some other time we should keep it as deleted. And that case-by-case thing makes it so complex. As a matter of fact, I dig the rabbit hole even a little bit further. Then I try to play with other strategies to do the merge of the conflict. Here I'm just going to brief them, because at the end of the day, I rejected all of them. Let me know in the comment below if you want me to talk more about it. The first one is manual resolve. That is when a conflict like this shows up, ask the user to resolve it. I don't want to go there because it's more work for the user. They will need to decide what to do when there's conflict. It's more dev work. I'll need to build a UI for merging conflicts. Then there's time-based auto-resolve. That is, we put a timestamp on the object for the last editing. And then we put a rule there to say either the first editing when or the last editing when. That leads to a situation close to, say, deletion always when. That would work for some, doesn't work for others. Plus, for all these merging, there is a hidden cost that I don't like at all. That is, it always requires to open the file, read something before we decide what to do. Get the value, get the deletion status, or get the timestamp. Thinking about doing that for every single data point in the whole system, that's not going to be efficient. And then, one idea struck me, and that is immutable. Let me show you what I mean. Let's slow down and think carefully. What is that caused the complex scenario? Yes, it is the merging of conflicts, but what caused the conflict? It is the fact that we allow editing the content of the file. So what would happen if we do not allow editing? In other words, we make the file content immutable. Then it's the binary case whether the file is there or the file is not there. The simplicity comes from if the file is there, it's safe to assume the content is the same. But you might ask, are we not going to allow editing or deleting? Where are we going to put the value for is deleted? What if the user needs to correct an existing value? Those are all well supported, but in a slightly unconventional way. Let me show you by demos. Here on the left side, you are seeing a CLI that is primarily used to manually testing the functionality of CodeNameK. And on the right hand side is the local data storage for the CLI. Let me start the application. At the beginning of the app, it asks me, do you want to start a sync with your OneDrive? I'm going to say no for now. And then it lists all the categories. And it is one-to-one mapping to the folders on the right hand side. And it prompts, pick a category for the next operation. For this demo, I'm going to use the new category. Let's name it Demo1. A folder has been created on the right hand side. Now it asks me to add a new value. I'm just going to put in something randomly, 2000 for example. And we'll see, one file is created on the right hand side. Back to the CLI, pick a dot to delete. Let me copy and paste the ID for the newly created data point, which is 5C blah 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 blah. You'll notice on the right hand side, instead of the data point file being gone, there's actually another file that's being appended. It has the same GUID as an ID, but a different file extension, so that the app knows it is a deletion marker. When we load the data points from the disk, those with deletion marker will be ignored. But when we do the sync, the operation of deletion has been converted to adding. And again, adding is very easy for syncing. And how about editing? Well, you might already guessed. Editing is converted to deleting and then add new. Let's see it in action. Here, since to the app, the data point of 5C has already been deleted. I cannot update it any further, so let me restart the CLI. And I'll add another data point into the same category, but instead of deleting, I'm going to update the value. The first thing we notice is, although there are 3 files on the disk, the app treated it as if there's only one data point. And that's a new data point that I've just added in the second run. Now I'm going to skip the deletion, and it prompts, do you want to update a data point? Input the GUID if you want. And I said, B22 blah 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 blah. And it pulls up the value, 2500, and then asked, what's the new value? And I said, 2600. And it asked, what's the new time? And I kept silent. So it thinks, okay, you don't want to provide a new value for the time, then I'm going to use the existing value. And then it asked it again, what's the new category? And I kept silent again, and it thinks, okay, I'm going to use the existing category. Now that it has everything that is needed to update a data point, it put the deletion marker along the side of the existing data point, so they become 4 files now. And it created another new data point identified by FF8, blah blah blah. And it becomes 5 files. Up to this point, we created a point, deleted it, created another, updated it. Effectively, there should be only one data point, and there's no change, not even once, in the file content. And this way of making file content immutable works extraordinarily great in the scenario of two-way syncing. What you're going to see next is I'm going to push this change into OneDrive, and I'm going to sync the change to the WPF client. And I really enjoy the process. Ready? Go! Alright everyone, thank you for joining me today. Keep coding, keep improving. Merry Christmas and Happy New Year. And I'll see you in the next one. Until then, take care.